Welcome everybody to chapter 3, the goods market. After you have worked through this chapter, you should know the composition of GDP. You should know which variables influence the different components of the demand for goods. You should also know which variables are exogenous and endogenous, and how to determine the equilibrium income with a graphical tool or with a formal tool. You should also be able to analyze shocks, how shocks influence the economy, and this discussion should be performed in a verbal, graphical, or formal way. You should also be able to talk about the relationship between investment and savings and why the paradox of savings exists. So, a pretty long list of learning objectives. Let's get started. In the first equation, you can see the different components of aggregate demand. Aggregate demand is abbreviated within Z. Then you can see their consumption of the private households, investment of the private companies. Then G stands for government spending and the difference between exports and imports. Now we come up with the following assumptions: that we only look at one good. This one good can be used as a consumption good, investment good, but also for government spending. Then we also assume that supply is completely price elastic and therefore demand determines supply. On the next slide, I'll focus a little bit more on this assumption. And I'll explain in detail what the consequences are when we make this assumption. Furthermore, we want to focus on a closed economy so that exports and imports do not play a role. Exports and imports do not pop up in this chapter anymore. Therefore, the demand for domestic goods, the Z, is equal to consumption, investment, and government spending. On the next slide, I would like to talk about this second assumption, that supply is completely price elastic and therefore demand determines supply. Let's have a look. I would like to talk about this on this slide. In the left part of this slide, I would like to analyze a scenario where supply is elastic, and in the right part, the situation where supply is inelastic. How does the supply curve look like in case that supply is inelastic? In case that supply is inelastic, then the supply curve is a vertical line. So this is our supply curve in case that supply is inelastic. And when supply is completely elastic, then the supply curve is a horizontal line. In the intersection of the demand curve and the supply curve, we find our equilibrium level of income. So let's label the initial equilibrium. This is point A, Y, A, and the price level is equal to PA. Let us now analyze what happens if a negative demand shock hits this economy so that the demand curve shifts to the left. I'll use a different color. I'll use a color red here for the new demand curve. The demand curve shifts to the left because of the fact that a negative demand shock hits the economy. And then at a given price level A, it will be the case that demand is on the level A prime and supply is on the level A. In case that supply is larger than demand, prices will decrease. So over time, it will be the case that prices decrease and the quantity demanded will increase again until we reach a new equilibrium here in this point B. Prices have decreased to the level PB and GDP is on the same level as before. So YA is equal to YB. In case that the supply is completely inelastic, this demand shock is digested in a way that the goods prices decrease, and then demand for domestic goods will pick up again. In this situation, the economy is getting out of a recession, and we don't have to be concerned about unemployment in this situation, because GDP level A is equal to GDP level B. So employment is on the same level, and therefore there is no unemployment problem. Let's check in the left diagram, where supply is elastic, how a negative demand shock is digested. Also here, the negative demand shock arrives. The demand curve shifts to the left, and we get a new equilibrium in the intersection of demand and supply. This is point B, Y, B, and P, B. Let's also label the initial equilibrium. This is point A. I'll switch the color. This is point A. The price level in A is the same as the price level in B, and the GDP level in the initial situation is on YA. So when our economy is displayed by the left part of this diagram, then of course we have to be concerned about this situation. Prices are sticky, prices do not adjust, and therefore our economy ends up in a recession. Point B is an equilibrium, so we'll stay in this equilibrium forever. Employment is on a lower level in B compared to A, so that the unemployment rate is higher in B compared to A. So we have a high unemployment rate in point B. The economy is in a recession. What can the government do in this situation? The government could try to stimulate demand and could try to shift the demand curve back to the right. So here it could be the case that the government is doing something, for example, increasing government spending or decreasing taxes, so that the demand for domestic goods picks up again. And in case that the government is reacting in this way, then in the end, the economy could end up in point C, so that the GDP level is back on track. GDP in A and C is on the same level, and the prices in C are also equal to the price level in A. So in case that the supply is inelastic, then the shock will be digested by a decrease in prices. But when the prices are sticky, when the prices are stuck on the level A, because of the fact that the supply is elastic, then the economy will not get out of recession by itself, but the government has to do something. The government has to increase demand for goods. So the second assumption is very important. Supply is completely price elastic. Demand determines supply. In case that there is a negative demand shock, then the economy will end up in a recession. And in case that there is a positive demand shock, the economy will end up in a boom. This assumption is very important, but due to the fact that the supply curve is completely horizontal, we will not work in this price quantity diagram anymore. We will not work in a price quantity diagram because of the fact that this is not of our interest, because we know that the goods prices will be constant in case that the supply is completely price elastic. In our goods market model, it is the case that the prices are fixed, the prices do not change, and therefore in chapter 3 we cannot explain the phenomenon of inflation. So inflation will not pop up in chapter 3. In equation 1, we are assuming that consumption depends on disposable income. In equation 2, we are getting a little bit more concrete and we are specifying this consumption function. Consumption depends on C0, which is the autonomous component of consumption, and we are assuming that this variable C0 is larger than 0, so it is positive. Then we have one term which depends on disposable income. C1 is a parameter, and this parameter is called marginal propensity to consume. C1 is also positive, and C1 is between 0 and 1. Disposable income is defined as gross income Y minus the taxes, so disposable income is equal to Y minus T. When we insert Y minus T instead of disposable income in equation 2, we get to equation 3, so that consumption is a function of the autonomous component of consumption plus the marginal propensity to consume, and then in brackets disposable income. Let's talk a little bit more about these different terms. So we are assuming here that consumption depends on disposable income. Let's assume that C1 is equal to 0.75. What does it imply? It implies that when disposable income increases by 1 unit, let's say here by €1, then it will be the case that consumption is up by 75 cents. The remaining part, which is not consumed, like the 25 cents, they are saved. So the parameter C1 indicates how much a household will consume and how much the household will save. Then we also have this autonomous component of consumption, and here we are assuming that a lot of factors can affect the consumption of a private household, but we are not going to specify it. For example, it could be the case that one household is looking very optimistic into the future. He expects that in the future he'll get a new job, he'll make a nice path in the career, and therefore he will spend more. Then the C0 variable could be increasing, or C0 could take a huge value. It could also be the case that one household believes that he'll get unemployed in the future because the neighbor to the left and the neighbor to the right is already unemployed, and therefore he's reducing the consumption. And then we have one variable which can pick that up. We can decrease the autonomous component of consumption. What about investment? Here we are assuming that the investment level is exogenous, and sometimes we put a bar above a variable in order to indicate that this variable is exogenous. Sometimes we'll also drop this overbar, but here in the first few slides we will use this overbar to indicate that a variable is exogenous. Government spending is also an exogenous variable, and therefore there is a bar above this variable. Now we can insert all the information we have in this aggregate demand function. So we are inserting the consumption function, the investment function, and the function for government spending. And then we arrive at equation number 4, which specifies the demand for goods. In an equilibrium, the supply of goods, the left-hand side of equation 5, has to be equal to demand of goods, so Y has to be equal to Z. Supply has to be equal to demand. So equation number 5 is our equilibrium condition. In the following, we would like to perform a graphical analysis, and I would like to display a numerical example. Let's have a look at the numerical values. The marginal propensity to consume is a parameter, and we assume that C1 takes a value of 0.75. The exogenous variables are the autonomous component of consumption, C0. We assume that this variable takes a value of 100. Taxes T take the value of 200. Investment takes a value of 150. Government spending takes the value of 300. Then, what kind of variables are endogenous? The supply, like the variable Y, is endogenous, and the demand variable Z is also an endogenous variable. The variable Y will be labeled as supply, but also will be labeled as GDP or income. Now we can insert the information we have into equation 6 or equation 7. What is the difference between equation 6 and 7? We tried to get rid of this bracket here, so we were multiplying through. C1 times minus t gives you, like this, minus C1t, and then we have a plus C1y, and you can find this term in the last part of equation 7. So we sorted the elements in a way that we have the autonomous components in the first part of equation 7. Now we can plug in the numbers we have. C1 is equal to 100. Then we have minus C1t minus 0.75 times 200 plus 150 investment plus government spending is equal to 300. And then the last term is 0.75 marginal propensity to consume times the Y variable. We can combine the autonomous components, and when we take the sum here, we have minus 0.75 times 200, which is minus 150. This minus 150 will cancel out against this plus 150. And then we have this 100 here and the 300 there. So the sum of the autonomous components is equal to 400. What we are going to do is we want to display this aggregate demand function in one diagram where we have the income Y on the horizontal axis and we have the demand Z on the vertical axis. In case that the income would be equal to 0, demand would be equal to 400. So this is the intercept of the aggregate demand function with the vertical axis. So the aggregate demand function starts at the value of 400. So the sum of the autonomous components, they determine this y-intercept. Then it's also the case that this curve should have a slope of 0.75. Slope of 0.75 implies that when we go 1000 steps to the right, the curve should go 750 steps upwards. Normally, we always say we want to go 1 step to the right and 0.75 step upwards, but here we would not able to see anything in this graph because of the fact that this would be too small. When we only get 1 step to the right, we would not be able to see this in the graph. Since the aggregate demand curve is linear, like we are allowed to augment this factor, hence we go 1000 steps to the right, the curve goes 750 steps upwards, so the slope is 0.75. We can of course also determine the slope by computing the differential. dz dy is equal to 0.75. So that our aggregate demand curve has a positive slope. In the next step, I would like also to insert the equilibrium condition. The equilibrium condition is this blue line here, and it is a 45-degree line. and it also goes through the origin. Along this line, the equilibrium condition is fulfilled. Along this line, supply is equal to demand. Now we have to look for the intersection of the equilibrium condition and the aggregate demand function, and hence we get the information that the equilibrium level of income, the equilibrium level of GDP in our economy, is equal to 1,600 units. After we have defined this equilibrium, we always want to come up with a shock. Like we want to shock this equilibrium and would like to know how does a shock change the equilibrium level of GDP. Perhaps for you a shock is always a negative thing, but here we define that shock is just a change. The change can be positive, the change can be negative, so a shock can be positive or negative. What we want to assume here that the government increases government spending from 300 to 400. So now government spending takes a value of 400, and the change in government spending is equal to plus 100. So DG, the change in government spending, is equal to 100. How does this affect our graph? We have to think about where government spending stands in our equations. And it is here that government spending affects the autonomous component. And when government spending increases from 300 to 400, then the autonomous component will increase from 400 to 500. And this will affect where the aggregate demand curve intersects with the vertical axis. The aggregate demand curve will shift upwards to the level of 500. This is displayed in slide number 14. The ZZ function shifts upwards. The red ZZ function is valid. It gets a new label here. ZZ0 was the previous aggregate demand function, and ZZ1 is the new one. Then we have to look for the intersection of the ZZ1 curve and the equilibrium condition. And we can infer from this graph that the GDP increases are to the level of 2000. And this is very interesting. The government increases government spending by 100 units, but the GDP increases by 400 units. So it's indeed the case that a multiplier is working here, and like with 1 unit of additional government spending, the government would be able to increase GDP by 4 units. Here in this graph, the government increases government spending by 100 units and GDP is up by 400 units. We have performed now a graphical analysis. What will always follow is a more formal analysis. In a first step, we will determine the equilibrium level of income, and afterwards we will examine what happens if the government increases government spending. So the line of analysis, the path how we analyze this shock is the same when we perform a graphical analysis or a formal analysis. So let's compute the equilibrium level of income. We have to combine the aggregate demand function and the equilibrium condition, and we are inserting the right-hand side of the aggregate demand function into the equilibrium condition. Then we get here this relationship on the left-hand side, goods supply Y, should be equal to goods demand on the right-hand side. We would like to compute the equilibrium level of income, and there is one problem, and the problem is that income pops up on the left-hand side and on the right-hand side. So we have to put this C1y term on the left-hand side. We have to subtract C1y from both end sides of the equation, and we get to this relationship here. In the first step, we have to get rid of this bracket, so that on the right-hand side we get a minus C1t, which is here, and then we put this plus C1y on the other hand side, get a minus C1y here. We can write y out of brackets, which we did here, so y out of brackets, we get a 1 minus C1 times y. In the next step, we can divide this relationship by 1 minus C1 so that we have isolated y on the left-hand side of this equation. So we are dividing the right-hand side and the left-hand side by 1 minus C1 and get to this relationship here. Now it is the case that we have isolated y on the left-hand side and we can compute the equilibrium level of income. Let's plug in all the information we have. Like here in brackets, we once more have our autonomous components, and we know already that the sum of these autonomous components is equal to 400. Then we have here in front of this square bracket this fraction 1 over 1 minus C1. 1 minus C1 is equal to 0.25. 1 divided by 0.25 is equal to 4. So the equilibrium income level in the initial situation is equal to 4 times 400 equal to 1,600. Already on this slide, we can examine what happens if the government increases government spending from 400 to 500 units. Then the sum of the autonomous components will take the value of 500, and hence it will be the case that the new GDP level is equal to 2,000. I would like to make a break here. Please take some time and review what was going on in this part of chapter 3. I will continue with another video. Thank you very much. Bye bye.